Hello, Econ 201 students. Today we'd like to talk about Chapter 2, How to Think Like an Economist. In this chapter, we also need to find the answers for several questions, right? So the first question we would like to find would be, what are the economists' two roles and how they differ from each other? And then we'll move on to talk about models. So what are the definition of models and how do economists use models to analyze the economic questions? And then we'll move on to production possibility frontier. Okay, so PPF is the most important concept in this chapter. We would like to learn how this PPF related to opportunity cost that we already learned in last chapter. Okay, so their relationship very important. How PPF related to the opportunity cost. And then we would like to talk about the last question, maybe just a brief introduction about what's the difference between microeconomics and macroeconomics. Okay, now let's move on to the first one. Economists always play two roles. Okay, one role is like a scientist. Okay, because we try to explain how the world economy works. And then another role will be acting as a policy advisors because we try to make some policy suggestions and try to improve the economic situation. Okay, so these are the two roles that economists always play with: scientists and policy advisors. So we use we use scientific methods in economic analysis. This is very similar to what we call a hard science, like chemistry, physics, biology, okay? Because we need to first conduct a theory or hypothesis. And then we need to design an experiment, okay, to try to test those theories. And in order to test those theories, we need to collect data, right? And once we have data, we need to set up economic models and then do the analyze. Okay. So once we analyze the data, and then we might need to revise the hypothesis that we already set up, right? So these are something that's very similar to hard science because economy also do the research that this way. And another thing is something also different in economics because we were a little bit different from the hard science. Hard science always use the latest data, but in economic situation, we always use the historical data. Okay, and the lab that economists doing experiments is not in a just in one lab. It could be world round. Okay, it could be happened anywhere. Okay, so this is what we call the economists. Economists always play two roles. Okay, like a scientist, first we need to do some experiments to test the hypothesis or the theory correct or not. And then based on those analyze, we will provide our policy suggestions or policy recommendations. Now to the second part, assumptions and models. We would like to say the assumptions can help us to simplify the complex word and make it easier to understand. So in the first part, you need to put assumptions. I will give you an example. In order to start international trade, we maybe assume there are only two countries. They only produce two goods and then they start trading with each other. So only two countries, only two goods, those assumptions seems unrealistic, right? Because we have many countries in the world, we have tons of the goods and services in the world, right? However, this type of assumption can help us make an easier model, okay, and then to analyze international trade. Model is a highly simplified representation of more complicated reality. Okay, so for the second part, you should put model. Models is a simplified. Models are the highly simplified representations of a more complicated reality. And economists use models very often, okay, to study economic issues. So those are some information about assumptions and models. Then we'll move on to the most important part of this chapter. The first economic model you will learn in this class, production possibility frontier, okay? So this will be our first model, production possibility frontier, always abbreviated as PPF, okay? So PPF, sometimes in other textbooks, it might call it as a PP curve, PPC, okay? Production possibility curve. PPF or PPC, in our textbook, we use PPF. And you can see this is the definition of production possibility frontier, which is just a graph. Shows the combination of two goods the countries can possibly produce given the available resources and the available technology. Okay, so from this definition, we should learn there are several key points. First, PPF is just a graph. Okay, and it shows the combination of two goods. So we can have here several key points. Okay, first is just a graph, and then it shows combination of two goods. Not only not one good or three goods or even more goods, only two goods. Okay, and then it shows one economy can produce based on the available resources. So we have fixed resources and the available technology. Okay, so we say we only have the fixed technology. Okay, so those are the several important points that based on their PPF's definition. The assumption here we assume we only have fixed technology, right? The available technology. And the resources are fixed, okay? And there are only two goods. Only two goods, okay? So let's look at one example about how we can apply the definition of PPF to draw a graph. We assume there are only two goods, computers and wheat. Okay, only two goods. And only one available resource, that is labor, okay, and measured by labor hours. And we says the economy has 50,000 labor hours available, okay, to produce these two products. So I will just summarize things here. We have only two goods, computers and wheat. Let me just write it down, okay? Computers and wheat, right? And we only have one resource, that is labor, okay? So we have total labor hour per month will be 50,000 labor hours, okay? And then next part, we should know the technology, okay? So we assume produce one computer, okay? Produce one computer will need 100 labor hours, okay? 100 labor hours. And then produce 1 ton of the wheat. I just put one wheat, okay, but it's measured by ton, okay? 1 ton of the wheat required 10 labor hours, okay? So those are the given informations by this example. So how we can draw a PPF based on those information? Then look at this table, okay? We have different combinations, okay? So you can see the first the first column just show A, B, C, D, okay? The different A, B, C, D, just the different combinations. And then the second and the third column of this table shows the labor hours spending in computers production and weight production. Okay, so you can see for point A, let's look at just point A here. Okay, point A shows 50,000 labor hours all used in computers production, right? And there is no hours spending in weight production. So can you tell me how many computers will be produced based on this information? We know all the labor hours were spending in computers production, and produce one computer needs 100 labor hours, right? So we can use this 50,000 labor hours divided by 100, then it will give us 500 computers, right? 500 computers. So I'll say 500 computers. And how many tons of weight will be produced? None, because there is no labor hours spending in weight production. Divide 10, so 0 tons of the weight. So you can just put 500 and 0 in the first row, okay? In the first row. And then let's move on to point B. So in point B, what will happen? For point B here, similar, okay? You can see now we have 40,000 labor hours of spending in computers production, right? And then 10,000 labor hours spending in weight production. So here we can have at point B, we can have 40,000 labor hours spending in computers production. So divide 100. Then here we will have 400 computers. And can you just count how many tons of weight will be produced? We will have 10,000 labor hours, right? And then divide each tons of weight needs 10 labor hours. So totally here we will have 1,000 tons of weight. Okay, and similar like this way, you can compute point C, D, E, and then show different combinations of computers and weight. Okay, so let's move on. For computers now, you can just see at point A, we have 500 computers, right? And then 0 tons of the weight. So let's just let me just pull out this table. For point A here, I will have computers. And then we will have the weight, okay? So for a computer, point A here, we will have 5, let me just write it a little bit lower. Computer weight. So for point A, as we just compute, we will have 500 computers and 0 tons of the weight, right? And for point B, we will have 400 computers and 1,000 tons of the weight. And then for point C, if you go back to check the table, you will notice that divide the labor hours equally to produce computers and weight. So we will have 250 computers and 2,500 tons of the weight. And then for point D, let me just go back to check. Point D here, you can see totally we will have 100 computers and 4,000 tons of the weight. And then finally, for point E, if you go back to check at point E, all the labor hours spending in weight production, and there is no computer will be produced, right? So There is 0 computers, but 5,000 tons of the weight. Okay, so all these will fit in this table. Now, how we can draw a graph based on this table? So here, what you need to do, I will draw a graph here, okay? In this two-dimensional graph, okay, I can put the computers on horizontal axis, okay? Can you see that? Let me see. I will put computers here, okay? This will be computer. And then I will put weight on the vertical axis. Okay, so we have the weight on vertical axis and computers on horizontal axis. So for computers, point A, we have 500 computers. Let me see, it seems that you cannot see 500 here, so let me just move this graph a little bit higher, okay? This one could be a little bit brighter, right? Okay, so I put computers here. And then I put weights here. So for point A, we have 500 computers. So this is point A. 500 computers, but no weight, okay? And then for point E, you see, for point E, we have 0 computers, but 5,000 tons of weight, right? So I can mark point E here, 5,000 tons of weight, but no computers. Then you can link these two dots, and then you will have PPF, okay? So this is what we call PPF. You can also put, this will be point A, and this is point E. You can also see the point B, E, D, okay? B, C, E, D. You can also mark those points on this PPF. So you can see all those combinations here or on this PPF. Understand? So this is the way that you can draw a PPF. Now, let's just look at one question. On the graph, please find the point that requires 100 computers and 3,000 tons of weight and label it as F. Will it be possible for economy to produce this combination? Why or why not? Okay, so let's see. Let me just erase these, okay? This will be computer, and this will be weight. This is 5,000, this is 500, okay? Link these two dots, okay? You got a PPF. So this is what we call PPF. And then let's look at this question. It says, please find a combination of 100 computer, okay? So 100 computer, let me see. 100 computer and 3,000 tons of the weight. So let's see. 500 computers will be, we need to spend how many labor hours to produce 100 computers? Each computer needs 100 labor hours, right? So totally here for computers production, we need 10,000 labor hours, right? For the tons of the weight, we know each tons of the weight require 10 labor hours, right? Therefore, for the weight production require 30,000 labor hours, okay? Then how we can find this point? You just mark 100 computers and 3,000 tons of weight, and then you link this combination, okay? Let me see. You might find one point here, okay? And then you should label this one as point F. This point is point F. So do you think that point F is able to be produced based on the current labor hours? Of course we can produce it because totally we have 50,000 labor hours, right? And now producing computers and weight just need, if you sum these two, 40,000 labor hours, right? Which is still smaller than what we have because what we have is 50,000 labor hours, right? So point F is definitely can be produced. And then for the next point, please find the points that represents for 300 computers and 3,500 tons of weight and label it as G. Would this point be available to produced or not? So similar, okay, we can find 300, maybe at this one, and then 3,500 tons of weight. So this is point G. You can notice at this point G is already outside of PPF, right? So we would like to say this point G is very good combination. However, based on the current economic situation, it's unable for this economy to produce because if you can similar, okay, like a point F, we can see now if now we need 300 computers and 3,500 tons of weight, then how many labor hours will be used? So 300 computers and each computer needs 100 labor hours, which means here we need totally 30,000 labor hours to produce those computers, right? And then for the weight production, 3,500 tons of weight, each tons of weight require 10 labor hours. Then totally you sum these, then you will find we need 65,000 labor hours, which is already larger than this economy will have. Therefore, have point G here, this economy cannot be produced. Okay, so now you might notice actually based on the PPF, we can have the points like the previous one, A, B, C, D, E. Maybe this is point B. Okay, this is point C. You can see here from this graph, we can have different positions of the points. Those points on the PPF, like a B or C, they are very good combinations because they use up all their labor hours and they are good to produce. The points inside of PPF, like this point F, it's also able for this economy to produce. However, at point F, it probably cannot fully utilize all the labor hours, right? So there could be some waste happens in point F. Point F is able to produce, however, this point is not efficient for this economy. And then let's look at point G here. Point G already outside the PPF, right? The projection is already outside the PPF. So for point G here, is a very good combination, however, is unable to produce based on the current economic situation. Okay, so here I show you the three different projections of the points on the PPF. Okay, either on the PPF or inside the PPF or outside the PPF. So similar, okay, as I just mentioned here, like the point F here, it's able to produce, okay, this economy is able to produce, however, it cannot fully utilize all the labor hours, so it is not efficient. For point G, okay, if you just put it on the PPF, this graph, then you will see point G already outside the given PPF. It's good to produce, however, based on the current economic situation, we cannot to make it at point G. So let's look at a little bit summary, okay, about those points. Those points on the PPF, like previous one from A to E, they are possible to produce and they are efficient because they fully utilize all the labor hours. Some points inside the PPF, like point F, it's still possible to produce, however, it's inefficient. Other points outside the PPF, or what we say above PPF, they are good. They are good combination. However, it is impossible for the current economic situation to produce. Okay, so those are some summarized about what we need to know about those points on this PPF graph. Okay, now let's move on to the relationship between PPF and the opportunity cost. How we can link these two concepts together. So let me just erase these and then I will explain the relationship between PPF and the opportunity cost. Do you still remember the concept or the definition of the opportunity cost? In chapter 1, we said the definition of opportunity cost means what you need to give up to obtain the item, right? Okay, so we can also apply that concept into our PPF. So the opportunity cost of an item is just what you need to give up to obtain the item. And moving along a PPF. So let's see. Let me just draw the graph first. Look at what I move, okay? If I move downwards along this PPF, just compare with this could be point C, this could be point B, okay? So moving from point C to point B, what you can observe. I'm just making things here, okay? Moving from C to B, you can see that we have more computers but fewer tons of the weight, right? So we will have more computers but fewer weight. So what does it mean? Or you can see moving from B to C. Moving from B to C, we have more weight but fewer computers, right? So you can see if we move along this PPF, one product will decrease and another quantity of the products will increase, right? So we cannot increase both computers and weight at the same time, right? So moving along this PPF, we will shift the labor hours between these two goods. Okay? And do you still remember we done this type of the principles in our first chapter, right? Life is about trade-offs. So getting more of one good requires sacrificing the number of other goods, right? So you can see moving from PPF, we can have more computers, but we have fewer weight, which means we give up. We give up the quantity of the weight in order to have more computers. Okay? Now, we will use the slope of PPF help us to learn the opportunity cost of one good in terms of another good. Okay? So here, do you still remember the slope, the definition of slope, how you compute the slope? So the slope here showing, you can see there is two different mountain, right? One is steep and one is very flat. I have the question here for you. Which slope would you rather ski? For me, probably I would rather ski for the second one, the flat one, because I know nothing about ski. For my kids, especially my son, he will prefer the first one, like a steeper one. Okay? So when you describe the mountain is steep or flat, what we mentioned is the slope. Okay? So slope is just a number, okay? And then it can describe the direction and steepness of that lines. And in mathematics, how we can compute the slope? We use rise over run. So slope, I'll put it here, okay? So slope, we'll use rise over run to get a slope, okay? Rise over run to get a slope. You can see for the first one, okay, the slope will equal 5 divided 10. Okay, the first one, 5 divided 10, which will be negative 0.5. Okay, negative 0.5. And then for the second one, we'll use negative 1 divided 12, which will give negative 0.0. Okay, 0.8. Negative 0.08. So you can see the slope will be very different from these two mountains. In PPF, so in PPF here, we can still use the same, we can still apply the slope calculation, okay, to get the slope of this PPF. So from here, where you can measure rise and where we can get a run. This is what we can treat as run, okay? And this is what we can treat as rise. We use rise over run, so the slope of this PPF will equal rise over run. But you should also notice this slope is downward sloping, right? So we need to eat a negative sign here, okay? Rise is 5,000. The run will be 500, okay? So here you will have the slope equal negative 10. For mathematics, you can stop at this way, okay? So the slope of the PPF equal negative 10. However, in economics, we need to figure out what's the implication of this negative 10. So this negative 10 here, very important, okay? This negative 10 here has special economic implication. It tells you in order to get one more computer, because we have the computer on horizontal axis, okay? In order to get one more computer, we need to give up or sacrifice, okay? I'll just say give up or decrease, okay? 10 tons of the weight. Any sense or not here? The slope equal rise over run. So we use 5,000 divide 500, get the negative 10, right? And you can see, in order to get one more computer, this is important. We have computers on horizontal axis. So this will be the opportunity cost of computer, okay? In order to get one more computer, we need to reduce or sacrifice 10 tons of the weight, okay? On the other hand, we can also say, I can also write something here, okay? The opportunity cost of one computer is 10 tons of the weight. Okay, so this is another economic implication of this negative 10. Okay, so negative 10 here can have two economic implications, either for this one. In order to get one more computer, remember computer on horizontal axis. Okay, in order to get one more computer, we need to give up 10 tons of the weight. Or we would like to say the opportunity cost of one computer is 10 tons of the weight. Understand? Okay, so the slope here as we just compute, okay? 5,000 divided 500 equal negative 1. So we will say the opportunity cost of one computer is 10 tons of the weight. The slope was showing the opportunity cost of something that we put on the horizontal axis. Okay, the slope was showing the opportunity cost that we're putting on horizontal axis. Emphasize again. Now let's look at another practice question. In which country the opportunity cost of growth is lower? Okay, so there are two countries. So we need to figure out in which country the opportunity cost of growth is lower. So you can look at these two graphs. Okay, we have France, we have England, and we all have the growth on the horizontal axis. So here it will be easier for us to just apply slope. So you need to figure out the slope of the first country, okay? So let's just do it together. How to compute the slope of France based on this PPF. It's a little bit hard for me to erase on this grass, so it probably takes some time, sorry. Well, similar, okay, we use rise over run. Can you tell me the first one? The rise over run, you can see we have the growth on horizontal axis and y on the vertical axis, right? So let's see. For the England, for France, how to get a slope. Let me check the numbers here. So we have y, it will be 600, okay? So 600 units of the y, that will be our rise, right? And then for run, how many tons, how many crows? 300, right? So we need to add the negative sign because it's downward sloping. Therefore, we get negative 2. So this slope will tell us the opportunity cost of one piece of cloth in France will be 2 units of wine. Okay, so this will tell us the opportunity cost of one cloth is 2. I just put 2 wine. Okay, 2 wines. Then let's look at England. Similar, okay, get a slope. So the slope will equal rise over run, but we need to put a negative sign because it's downward sloping. So we have 200 units of the wine and then 300 units of cloth. Okay, so negative 2/3. So it will like 2/3. You can just use your calculator to get this number here equal negative 0.6. I just put 0.67. Okay. So we would like to say the opportunity cost of one cloth in England, okay, is nearly, okay, 0.671, okay. So compare with these two numbers, which country will have a lower opportunity cost in producing cloth? Definitely, which one? England, right? This one is smaller. So England will have a lower opportunity cost of cloth production. Understand? Okay, so before we talk about before we move on to the new content for this chapter, okay, I just want to emphasize that if we want to use the slope to get the opportunity cost, it should be the opportunity cost of something that we're putting on the horizontal axis. Then we can use the slope, okay? So let's move on to something new about the PPF, okay? So do you still remember when we talk about PPF, we said there are several assumptions, right? We produce only two goods, right? And then we need to produce based on the available resources and the available technology, right? So we have several assumptions. So we can say there are three assumptions: two products, the available or fixed technology and fixed resources. If the assumption changes, what will happen to the PPF? So, for example, if we have more resources, we have renovated technology, what happens to the PPF? Then it will help us, the PPF, to shift outwards. Okay? So we like to say with additional resources or improvements in technology, then the economy here can produce more products, more computers, more weight, or any combinations between, right? So it will shift this PPF outwards. Does it make sense? I think so. If we have more technology, we have more resources, then we can have more computers and more weight, right? And then if we have the technology innovations in weight or computers production, even we only have fixed resources, we can also producing more computers and more weight. Okay, now let's look at another new part about the shape of the PPF. So PPF, as we just talked about, is just a straight line, right? The straight line means the slope is always the same. So the PPF could be a straight line or could be bow shape, okay? So bow shape PPF is very common in our reality. It determines on how the opportunity cost between these two goods. So if the opportunity cost always be constant between these two goods, then the PPF will be a straight line. Okay, so for example, as we just compute, the opportunity cost of one computer is always 10 tons of the weight. Okay, so we notice the slope will be constant. Therefore, it's a straight line. However, if it's a bow shape, what will happen? Let me just draw a graph for you. Okay, so if I put this was a bike, or I would just put something like a point, if like a good A, this will be good A, and this is good B, okay? And then now the PPF is like this shape. If the PPF is like this shape, what will happen? So I will just put 2 points, okay? Point A, okay? And I will give you another point. as point B. So look at point A and point B. First, I need you to draw a tangent line. Okay, so for point A, you draw a tangent line. And then at point B, you also draw a tangent line. Okay, so can you tell me the slope of point A? The slope of this point A and then the slope of point B. Which one would be steeper? Okay, you can see point A is relative factor, right, compared with point B, because point B seems steeper, right? So point A and point B, they have totally different slope, or what we say, point A and point B will have totally different point slope. And we will also see that if we move along this PPF, the slope will become steeper. The point slope will become steeper, right? Which means A and B, they will have different slope. And then A and B will have different opportunity cost. So we would like to say, if the opportunity cost of one good increases as we have more of these goods, then the PPF will be bow-shaped. Okay? Make sense or not here? Because slope B is steeper. Okay, it's steeper than slope A. And slope means the opportunity cost of good B, right? So we like to say the opportunity cost of good B in point B is higher than the opportunity cost of good B at point A, right? So as we move along this PPF, when we have more good B, the opportunity cost also increase. And this is why this PPF will become bow-shaped. Okay? So you can see this graph is a little bit weird because the color will be different. Okay? So here you can see in this example, very similar to the one that I just draw here. Okay? As the economy shifts resources from beer to mountain bike, okay, or from good A to good B, then we notice the point slope become steeper, like as I just write down on the board here. Therefore, the opportunity cost of one extra illness of good B increases, and that would make this PPF become bow-shaped. Okay, so any questions about this part? I hope you can understand. Now let's just look at a summary about PPF. So PPF shows all the combination of two goods in an economy that can be produced based on the available resources and the available technology. Okay, so three assumptions: two goods, fixed technology, fixed resources. PPF also illustrates the concept of trade-off or opportunity cost, right? And then it also shows the efficiency or non-efficiency, unemployment, and the economic growth. Okay. We also talk about if the assumption changes. For example, if we have more available resources, what we have improvement in technology, then the PPF could be shifted outwards or inwards. Okay. And we also talk about the different shape of PPF. It could be a straight line. It could be a curve. Now let's look at one practice question. With regard to the PPF, an efficient point is a point that should be impossible to reach. Is it correct? I don't think so. Inside a PPF, do you think inside a PPF is an efficient point? No. As we talked about before, the point F, as we labeled before, okay, in the previous slides, economy is able to produce. However, it cannot fully utilize all the labor hours, right? So any points inside the PPF is inefficient. Any points outside the PPF, it's very good. However, for the current economic situation, it's unable to produce, right? So only point D, only option D, okay, on the PPF are the points that possible and efficient. Okay, so those are the concepts, or those are the content for this chapter. And as I mentioned, this chapter actually we will talk about microeconomics and macroeconomic differences. And actually, microeconomics, as you can see from the micro, this word, okay, it means small, which means we will focus on one household, one firm, one market. So we will like to put the research on microeconomics on single unit. However, or single agent. For macro, it look at the problems more broader. Okay, so in macroeconomics, we look at the inflation rate, we look at the unemployment rate because we try to broad give you a broader information about economy. So I think that will be the biggest difference between micro and macro. And I think it's the end of this chapter. Thank you.